Okay, so we are now on number 5 and 6. So we've done number 1, 2, 3, and 4, all examples of simplifying rational expressions. These are a couple of slightly trickier ones. Number 6 in particular, I grabbed it from the homework, pretty much just copied and pasted it because I thought it was just a little tricky. It's so short, but maybe a little tricky. So anyway, here's number 5 and 6. And then I think after that, just looking ahead here, we just have really one more example to do involving factoring out a -1. So we're getting close. Oh, shoot. Sorry. Oh, no. Hang on. I got off. Let me fix this. I'm pausing. Okay, back where we were. Sorry about that. Let's do number 5. Once again, we're going to factor the numerator, factor the denominator, and cancel. It's just that for number 5, there's just a little bit more steps to the factoring for each of these parts. So for number 5, in the numerator, there is a common factor of 5. 5x squared minus 80, I can factor out of 5. 5, and then x squared minus 16, because 80 divided by 5 is 16. Now, you might notice x squared minus 16, there's more we can do, but I'm going to just save it for now, one thing at a time. I just factored out of 5. I can also factor out of 5 in the denominator. So I'm going to do that next. I'm kind of going back and forth here. You can continue factoring the numerator if you prefer, and then cancel out common factors later. I'm going to sort of break it up and do it in sort of 2 rounds here. In the denominator, 5x squared plus 25x plus 20. There's a common factor of 5 there as well. So I'm going to factor out of 5. 5x squared divided by 5 becomes x squared plus 25 divided by 5 becomes 5x, and then 20 divided by 5 is 4. Okay, so in the numerator, so far we have 5 parentheses x squared minus 16. In the denominator, 5 parentheses x squared plus 5x plus 4. So we can now cross out our common factors of 5. We're not done. There's more factoring we can do. So we can factor the numerator more. X squared minus 16 is factorable. Same thing with the denominator. There's 2 different types of factoring here. So let's continue. X squared minus 16 is going to become x plus 4, x minus 4. That's a difference of squares. And then the trinomial in the denominator, 3 terms in the denominator, x squared plus 5x plus 4. We set up 2 parentheses. They both start with x. And we're going to need factors of 4 that add to 5. So it's not 2 and 2, it's going to be 4 and 1. So I'll do plus 1 and plus 4. Or you could write plus 4 plus 1. Same idea, same thing. The order doesn't matter as long as you have both of those numbers. So if you did the x plus 4 first, that might be a little more obvious that these x plus 4s can cancel out. But I purposely didn't write it directly underneath because I want you to see that no matter whether the common factors are right on top of each other or a little bit diagonal, either way, you can still cross them out. So there is a common factor of x plus 4 that we can cross out in the numerator and denominator. So now we're done. Our final answer is x minus 4 in the numerator over x plus 1 in the denominator. You can leave the parentheses around the factors or you don't need to. Don't go any further. We're done. That's as far as you can go. You cannot cross out the x's because we can't factor out x. There's no more factoring we can do. X minus 4 is just x minus 4. Nothing else can happen there. Same thing with x plus 1. No more factoring. So just make sure as you're factoring and canceling, you don't take it too far and start crossing things out that you really shouldn't. Okay. Which leaves us with number 6. So it's kind of a short looking problem, but there's a couple of different formulas that we need to know in terms of how to do this one. Again, with the crossing out, don't cross out the B's, don't cross out the C's right now. I know they're right there. It looks like you can do something, but we really can't do anything until we fully factor the numerator and fully factor the denominator. My guess is for most of us, the denominator, the bottom, is a little more recognizable. B squared minus C squared, that is a difference of squares. It's the A squared minus B squared pattern, only it's B squared minus C squared. So the original formula would be A plus B, A minus B. In this case, it's B plus C, B minus C. So same formula, just different letters. So difference of squares, I'll type that here for the denominator, difference of squares. A plus B, A minus B is the pattern. Obviously different letters in this problem. Now the numerator is a difference of cubes. That's a little harder. It's a longer formula that hopefully we've been working on memorizing. So go look that up. I think it's, I forget the section, lesson 36, maybe it's special factoring. So go and find that formula if you need it. But that's what we're going to be using to fully factor the numerator. Okay, I'm actually going to take this one to a slightly bigger blank screen, so I have a little more space to write this one. Once we get the formulas written out, though, it's a pretty quick canceling process. All right, so I switched my screen. We're still on number 6. Let's see, sorry. B cubed minus C cubed in the numerator over B squared minus C squared in the denominator. Okay, so the denominator may be a little easier. Let's do that one first. Oops, that's going to be B plus C, B minus C. Because again, that's the difference of squares. Okay, and then the difference of cubes, maybe you've looked up the formula at this point, but if you haven't, I'll just remind everybody what it is down here. Here's the original formula, A cubed minus B cubed. Remember, we learned 2 of these, a sum of cubes and a difference of cubes. This is the difference with the minus. So it goes like this, A minus B, and then A squared plus AB plus B squared. Almost mixed up the sign there. That sign in the middle is always the opposite of the beginning. So the A minus B is followed by A squared plus AB. If it was A plus B, it'd be followed by a minus sign. So those are always opposite. Same, opposite, always positive. For the last one, meaning this first sign is the same as your original problem. The second sign is always opposite. And then the last one is always positive. Soap. Maybe I've shown you soap at this point as well. All right, so that's our formula. So you pretty much have it, just instead of A and B, it's B and C. Okay, so here is what the numerator will be. All right, so it goes like this, B minus C. And then the trinomial part goes like this, B squared plus BC plus C squared. Okay, so remember with cube formulas, they're long, but that trinomial part, this longer part of the formula, don't worry about factoring it anymore. It will not be factorable. So if you're staring at that wondering, can I do anything else with that? Nope, that's it, you're good. So now that we've factored the difference of cubes in the numerator, the difference of squares in the denominator, we're almost done. All that's left to do is cancel out your common factors, B minus C. So the B minus C's cancel out, and what we're left with is B squared plus BC plus C squared all over B plus C. Okay, I'm going to go back to our other screen so we can write the answer in there if you haven't already. All right, so in case you didn't get it, here it is again. Final answer for the numerator after we canceled out common factors for number 6 was like this, B squared plus BC plus C squared, that whole trinomial over B plus C. Because what we canceled out is the common factor of B minus C in the numerator and the denominator. And I know there's lots of B's and C's that you're looking at, but we're done. There's no more canceling that we can do because there's no more factoring that we can do. There's no more common factors. That's an entire trinomial that cannot be factored in the numerator, and then B plus C also cannot be factored in the denominator. All right, I think we just got one more.